South Pole. This is another magnet, North Pole, South Pole. Both are same. By seeing the picture, both are same. Rendu same ah? Kaadu. Etla different? In terms of its length. Ante kada. In terms of its length. Automatically, when you length is change, something to change. But that was a different. Or here I wrote a D first. So what is D? What is 12? Actually, from center magnet. Also length. So total how many lengths are there? And SD both are same. If I write small length, in both the cases? No. Pole strength is same. Also going to be different. Okay, means to show the change. Okay, so magnet how many? Generally magnet nature is to attract magnetic substance, and magnet has got how many poles? 2 poles, north and south pole, and these poles are separated, and when I multiply the pole strength with their separation, then I got a capital M. What is capital M? Magnetic moment. Magnetic moment. Pole strength. Capital M. So how a small m changed into capital M? By multiplying with the separation between the poles. Okay na? Right. So finally you got some clarity that magnet has got 2 poles, north and south pole according to directive property. And can we separate poles? We cannot separate poles. Right. Now if you take a magnet, what the magnet will do? It will attract a magnetic substance. It will attract a magnetic substance. So one iron nail I will keep here. This is what? Iron nail. Iron, a nail which is made up of this gap is there, na? Decrease this gap. From here to here you shift. No. 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 If you keep here, it is attracted. From here, no attraction, but when you keep here, it is attracted. Like that, we can see in all directions. North pole, south pole, so around a region, around the magnet, in this region, in magnetic substance, 2 dimensional ఉందమ్మా 1 dimensional ఉందమ్మా? It is a 3 dimensional one. It is a space. Okay, right. Magnet, north pole, south pole. Magnet attract magnetic substance, and when the magnetic substance will be attracted, ఎక్కడన్నా అట్రాక్ట్ చేసుకుంటుందా? నో, ఇన్ దట్ ఫీల్డ్ రీజన్ స్పేస్ కాల్డ్ యాజ్ మ్యాగ్నెటిక్ ఫీల్డ్. ఒక క్లారిటీ వచ్చిందా? ఓకే, వాట్ ఈస్ మ్యాగ్నెట్ అంటే తెలుసు, మ్యాగ్నెటిక్ ఫీల్డ్ అంటే తెలిసింది. ఇప్పుడు వాట్ ఈస్ మ్యాగ్నెటిక్ ఫీల్డ్ ఇస్ మేడప్ ఆఫ్? అసలు మ్యాగ్నెటిక్ ఫీల్డ్ ఏముంది? కెన్ యూ సీ ఎనీథింగ్ ఎల్స్? ఇది ఒక మ్యాగ్నెట్ అనుకోండి, దీని చుట్టూ మనకు అనిపిస్తుందా? నథింగ్ ఈజ్ గోయింగ్ టు అపియర్. బట్ వెన్ యూ కీప్ ఎనీ మ్యాగ్నెటిక్ సబ్స్టెన్స్ అదేం చేస్తుంది? అట్రాక్ట్ చేస్తుంది. ఓకే, సో ఇక్కడ ఏం చేస్తుంటే సమ్ ఇమాజిన్ చేసుకుంటున్నాం. వాట్ వి ఇమాజిన్? మ్యాగ్నెటిక్ లైన్ ఆఫ్ ఫోర్సెస్. వాట్ వీఆర్ గోయింగ్ టు ఇమాజిన్? మ్యాగ్నెటిక్ లైన్ ఆఫ్ ఫోర్సెస్. ఎక్కడ ఇమాజిన్ చేస్తున్నాము? అరౌండ్ ద మ్యాగ్నెట్. అరౌండ్ ద మ్యాగ్నెట్ ఎంతవరకు? అప్ టు వేర్ దిస్ మ్యాగ్నెట్స్ ఎఫెక్ట్ ఈస్ present. Up to that region we imagine imaginary lines called as magnetic field lines. Oh, those magnetic field lines is called as magnetic flux. ఏమనొచ్చు? Magnetic flux. These are imaginary lines. Magnetic flux is nothing but magnetic line of forces which are imaginary where around the magnet. Whether these are existing or not, అసలు ఉన్నాయా? ఎస్. టేక్ ఎ మ్యాగ్నెట్. ఒక మ్యాగ్నెట్ తీసుకోండి, డిప్ ద మ్యాగ్నెట్ ఇన్ ద శాండ్. శాండ్ అంటే తెలుసుగా, ఇసుక. రిమూవ్ ఇట్, సపరేట్ ద పార్టికల్స్ ఇన్ ద పేపర్. ఒక పేపర్ మీద పార్టికల్స్ తీసుకోండి. బిలో ద పేపర్ కీప్ ద మ్యాగ్నెట్. బిఫోర్ దట్ పార్టికల్స్ అరేంజ్మెంట్ చూడండి. పార్టికల్స్ ఆ పేపర్లో పోసినప్పుడు ఎట్లా ఉంటాయి? సమ్ క్లారిటీ, ఒక పిక్చర్ ఉంటుంది. బిలో కీప్ వన్ మ్యాగ్నెట్ అండ్ ట్యాప్ ద పేపర్. పేపర్ని ఏం చేయండి? ట్యాప్ చేయండి. అప్పుడు వాట్ యు ఆర్ గోయింగ్ టు నోటీస్, అన్ని పార్టికల్స్ అపియర్స్ ఇన్ ద ఫార్మ్ ఆఫ్ లైన్స్. అన్నీ. ఓకే, అగైన్ వాట్ యు డూ, రిమూవ్ ద కీప్ ద మ్యాగ్నెట్ అవే, అగైన్ డిస్టర్బ్ ద పార్టికల్స్, అన్ని దగ్గరికి వచ్చేస్తాయి. మళ్ళీ నో నీడ్ టు కీప్ ద మ్యాగ్నెట్ టచింగ్ ద పేపర్, సమ్ గ్యాప్ కూడా పెట్టవచ్చు. డోంట్ మెయింటైన్ లార్జ్ గ్యాప్, సమ్ గ్యాప్. అగైన్ యూ ట్యాప్ ఇట్. మళ్ళీ ఏమవుతుంది? అగైన్ యూ ఆర్ గోయింగ్ టు సీ ద ప్యాటర్న్. సో ఎవ్రీ టైమ్ న్యూ ప్యాటర్న్ యూ ఆర్ గోయింగ్ టు నోటీస్. ఒకసారి వచ్చిన ప్యాటర్నే మళ్ళీ యాజ్ ఇట్ ఈస్ రాదు, కొద్దిగా డిస్టర్బ్ అటు ఇటు జరగవచ్చు. ఓకే, దట్ ప్యాటర్న్ కంటైన్స్ లైన్స్. ప్యాటర్న్ ఎట్లా ఉంటుంది? లైన్స్ అనిపిస్తాయి. మీరు ఎప్పుడు చేయాలి ఎక్స్పెరిమెంట్? అయితే చూడలేదా? సో ఎవ్రీ టైమ్ trend is changing. That's why imaginary lines. Imaginary lines. Where we see this? Around the magnet. Where? Up to where its effect is present. Magnetic field లోనే మాత్రం చూస్తాం అన్నట్టు. ఓకే, రైట్. ఈ మ్యాగ్నెటిక్ లైన్ ఆఫ్ ఫోర్స్ ఏమనాలి? మ్యాగ్నెటిక్ ఫ్లక్స్. అండ్ యూనిట్ ఆఫ్ మ్యాగ్నెటిక్ ఫ్లక్స్ ఇస్ వెబర్. మ్యాగ్నెటిక్ ఫ్లక్స్ యూనిట్ అంటే వెబర్. ఓకే, రైట్. ఫ్లక్స్ విత్ రెస్పెక్ట్ టు ఏరియా. ఒక పర్టికులర్ ఏరియాలో పర్టికులర్ నెంబర్ ఆఫ్ మ్యాగ్నెటిక్ లైన్ ఆఫ్ ఫోర్సెస్ ఇమాజిన్ చేసుకోవచ్చా లేదా? మ్యాగ్నెటిక్ ఫ్లక్స్ విత్ రెస్పెక్ట్ టు ఏరియా ఆఫ్ క్రాస్ సెక్షన్. ఇట్ మే బి, ఇఫ్ పై అనేది 5 ఉంది ఒక చోట, ఇంకో చోట 10 ఉండొచ్చు, ఇంకో చోట 15 ఉండొచ్చు. ఆర్ ఎల్స్ ఎల్రా దిస్ ఎ మ్యాగ్నెట్. Imagine lines are imaginary lines. Okay, and one more important point, when you draw these lines, no two magnetic line of forces cross each other. ekkada gaani two lines overlap kavu, cut kavu. Here appears to be, but when you do the experiment, you can see individual line. they form a loop. They form a loop, and like that many loops you can see, but there is no chance of crossing. Magnetic line of force never cross. Okay, right. So if I take A, and this is called flux, this line of force is called as flux. I will take this area of cross section A, and here A. Area of cross section is same or different? I took two areas, two spaces, same area, different area of cross section. Imagine the area of cross section is same, A is same. What is different? Here how many lines are passing? Here how many lines are passing? Same, same number of lines are passing. Here only two lines are passing. Here how many lines are passing? If I take like this, how many lines are passing? One. Here two. Here three. So flux with respect to area. Flux with respect to area we call as B. What we say? B. What is B? Magnetic flux density. Magnetic flux density. What is magnetic flux density? Pi by A. Magnetic flux density is pi by A. But what unit of pi? Weber. What unit of area? So unit is what? Weber per meter square, or it is also called as Tesla. Weber per meter square or Tesla, and one more unit is there, Gauss. CGS unit is Gauss. Tesla is a unit, Gauss is a CGS unit, or Weber per meter square. What is Weber? Unit of magnetic flux. What is magnetic flux? Magnetic line of forces. Magnetic flux is magnetic line of forces. Where we see this magnetic line of forces? In the magnetic field. What is magnetic field? Space around the magnet where its influence is present. Okay. So magnetic line of forces are real? No, they are imaginary. And from where to where they are going to travel? North pole to south pole, outside the magnet, and inside the magnet they travel from. So they form a, yes or no? Complete circle is forming or not? And magnetic line of force are going to cross each other? No, never crosses. Okay, na? Right. So magnet got two poles, north pole, south pole. Every pole, generally magnet exhibit attractive property, repulsive property. Two magnets, when you bring together, they may attract. If you orient one of the magnet and you keep together, it may repel. Two possibilities, either we see attraction or we see repulsion. When we are going to say attraction, when north kept near south or south kept near north, attraction. If you see south pole kept near the south pole of another magnet. Two magnets తీసుకొచ్చాం దగ్గర పెట్టాం, ఒక నార్త్ ఇంకో సౌత్ పెడితే ఏమవుతుంది? అట్రాక్ట్ అవుతుంది. ఇది నార్త్ రెండు నార్త్. ఎనీ అదర్ thing or any other thing you are going to notice? No, you are not going to notice any other thing beyond this. Either they attract or repel. When they are going to attract, opposite poles kept together. When they are going to repel, similar poles. Okay, na? Right. So attraction, repulsion. Attraction, repulsion. Okay. Next, a magnet. One more important point that you have to know is magnet attract magnetic material. Actually, magnet attraction takes place between two magnets. North and north repulsion annanu, north and south attraction annanu. This is one magnet, is another magnet. But in a magnetic field, when you keep any magnetic substance, that is also attracted. In magnetic field, magnetic substance పెడితే attract అవుతుందా లేదా? Magnetic substance. But here what is it? Two magnets మధ్య attraction అన్నాం. Two magnets మధ్య attraction. అమ్మా వాటర్. Thank you. టూ మ్యాగ్నెట్స్ ఏమవుతాయి, మ్యాగ్నెట్ మ్యాగ్నెట్ అట్రాక్ట్ అన్న, రిపల్షన్ అన్న. ఇక్కడ మ్యాగ్నెట్ అన్న, మ్యాగ్నెటిక్ మెటీరియల్ అన్న, డిఫరెన్స్ ఏంటి? మ్యాగ్నెటిక్ మెటీరియల్ మ్యాగ్నెటిక్ డిఫరెన్స్ ఏంటి తెలుసా? ద అటామిక్ లెవెల్ వెళ్ళాలి. మ్యాగ్నెటిక్ మెటీరియల్ విల్ బి కన్వర్ట్ ఇంటూ అ మ్యాగ్నెట్. మ్యాగ్నెటిక్ మెటీరియల్ ఏం చేయొచ్చు మనం? Alignment of dipoles here and here both are same. So where we see this type of alignment, one in is north pole, one end is south pole. Here any specific alignment is there. So this is a magnet and this is magnetic material. Difference ఏంటి? Atomic level లో dipoles regular orientation, random orientation. Okay, regular orientation one in north pole, another in south pole. Random orientation we can't specify which is north and which is south. But when this material is kept in the magnetic field, when this magnetic material is kept in the magnetic field, this random orientation changes to regular orientation. Random orientation with a regular orientation అవుతుంది, that is called induce. Then this will convert into a magnet. ఈ ఓరియంటేషన్ మారినప్పుడు ఏమవుతుంది, ఇది కూడా మ్యాగ్నెట్ అవుతుందా లేదా? ఆ మ్యాగ్నెటిజం ఏమనొచ్చు? ఇండ్యూస్డ్ మ్యాగ్నెటిజం. వాట్ యు సే? ఇండ్యూస్డ్ మ్యాగ్నెటిజం. Induction, induced. So this magnet will induce this material to behave as a magnet. Will orient the direction of dipoles. So magnet attracts another magnet, or magnet repels another magnet, and a magnet will convert a magnetic material into magnet, and depending upon the poles it may attract or repel. So here it will behave as a magnet in a magnetic field. That magnetism ఏమనొచ్చు? Induced magnetism. Induced, induction. Okay, what black shirt? What I am saying? Show your hand. Right, what I am saying? ఈ డయాగ్రాము అర్థమైందా? విన్నావా? చూసావా? అసలు ఎందుకు వేసా నేను? ఎందుకు కూర్చున్నావాడా? ఫస్ట్ స్టార్టింగ్లో కూర్చున్నావు, ఎట్లా ఉండాలి యాక్టివ్గా? How many poles are there for a magnet? Stand and answer. What are they? What are they? North, south. Why? ఎందుకు నార్త్ అండ్ సౌత్, ఈస్ట్ వెస్ట్ అనరాదా? ఎందుకు? ఆ ప్రాపర్టీని ఏమనాలి? డైరెక్టివ్ ప్రాపర్టీ. ఏమనాలి? డైరెక్టివ్ ప్రాపర్టీ. అంటే మ్యాగ్నెట్ని హ్యాంగ్ చేస్తే అది రెస్టింగ్ పొజిషన్కి వస్తుంది. నార్త్కి ఒక సైడ్, సౌత్కి ఒక సైడ్. The side which is towards north, north pole, the side which is towards south, south pole. So magnetic field, what is magnetic field? The space around a magnet where it's a repel. A magnetic line of force intersect అవుతాయి ఎక్కడైనా? No. And it is a line? No, it is a loop. Always extended from north pole to south pole outside the magnet, and south pole to north pole inside the magnet. These are real, imaginary lines. These are named as magnetic flux. Magnetic flux present in the unit area is called as pi by A, is called as B. What is B? Magnetic flux density or magnetic induction. Magnetic or magnetic induction. So what is magnetic flux density? B. Other name for magnetic flux density is magnetic induction given by pi by A. Units enti? Weber per meter square or Tesla. Weber per meter square Tesla. Right. So flux density, orientation phi is equal to B dot A cos theta. ఇంకో ఫార్ములా అంటే ఇప్పుడు ఏరియా ఆఫ్ క్రాస్ సెక్షన్ మ్యాగ్నెటిక్ లైన్ ఆఫ్ ఫోర్స్, ఇది ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఏ, ఇది ఫై. ఓకే, alignment is different. So in the if ఈ డైరెక్షన్ లో పై ఉంది, ఈ డైరెక్షన్ లో రెజల్యూషన్ వెక్టార్ రెజల్యూషన్ వెక్టార్ A is a vector which makes an angle theta with x axis, then theta. Component along y axis A sin theta. ఇది వెక్టార్ రెజల్యూషన్ అంటాం. దేనొచ్చు, సో దీని ఏమంటారు హార్జెంటల్ కాంపోనెంట్ ఏఎక్స్ అంటాం, దీని ఏమంటాము వర్టికల్ కాంపోనెంట్ ఏవై. And this is A. We can show that A square is equal to AX square plus, మీరు మ్యాథమెటిక్స్ పైథాగరస్ థియరమ్ ప్లేస్ వస్తుంది. సో హారిజాంటల్ కాంపోనెంట్ ఆఫ్ వెక్టార్ A is A cos theta and vertical component of vector A is A sin theta. దాని ఏమనాలి రెజల్యూషన్ ఆఫ్ వెక్టార్. వాట్ వీ హావ్ టు సే రెజల్యూషన్ ఆఫ్ వెక్టార్. ఇప్పుడు ఇది రెండు, ఇప్పుడు ఏరియా ఆఫ్ క్రాస్ సెక్షన్ కదా, రెండు సేమ్ డైరెక్షన్ ఉన్నాయి. ఫ్లక్స్ ఈ డైరెక్షన్ ఉంది, ఏరియా వెక్టర్ ఈ డైరెక్షన్ ఉంది, రెండు సేమ్. నో, ఏ డైరెక్షన్లో ఏరియా వెక్టర్ ఉంది, ఈ డైరెక్షన్ ఫ్లక్స్ ఉంది. ఫుల్ ఇది ఏ, ఈ డైరెక్షన్లో ఎంత ఉంది ఏ వాల్యూ, టోటల్ వాల్యూ ఉందా, ఏలో ఒక పార్ట్ ఉంటుందా, ఏమవుతుంది పై కాస్ థీటా. ఏరియా ఉంది కదా, సో టోటల్ వాల్యూ ఎంత పై సారీ బి 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 సారీ బి, ఈ డైరెక్షన్లో బి, పై ఈజ్ ఈక్వల్ టు area vector A, B value in this direction which makes an angle theta, అన్నప్పుడు B value according to this ఈ డైరెక్షన్ ఎంత ఉంటుంది B cos theta. ఓకే, సో టోటల్ ఫ్లక్స్ along this direction is equal to ఎంత, టోటల్ ఫ్లక్స్ A into phi is equal to B dot A. B is equal to pi by A. Pi is equal to B dot A. Cos 0 1 అంటే ప్యారలల్, అంతే కదా. θ is equal to 0 ఉన్నప్పుడు A and B are parallel. θ is equal to 90, cos 90 0 అంటే B వాల్యూ రెండు సేమా, if perpendicular, if parallel. ఇక్కడ θ ఎంత తీసుకున్నాం 90, ఇక్కడ θ ఎంత 0. సో ఫ్లక్స్ అంటే కరెంట్ ఎక్కువ, మళ్ళీ అక్కడ అప్లై చేసుకోవాలి. ఇండక్షన్ ఆల్రెడీ చెప్పాను కదా, ఎలక్ట్రిక్ మోటార్. ఓకే, చేంజ్ ఆఫ్ ఫ్లక్స్ ఎంత ఎక్కువ ఉంటే ఇండ్యూస్ ఈఎంఎఫ్ అంత ఎక్కువ ఉంటుంది. సో ఆటోమేటిక్ ఇండ్యూస్డ్ కరెంట్ ఈజ్ ఆల్సో గోయింగ్ టు బి ఓకే, రైట్. సో ఫ్లక్స్ density divided by A, where flux pi is equal to, from this equation, right, VA. If it is making an angle theta, then pi is equal to B dot AR BA cos theta. Flux. So what and what we discussed, tell me? Even discuss some definitions. Magnetic field, magnetic line of force, magnetic flux density. Meter for free space or vacuum. For a particular medium, it is indicated with mu. What is mu? Permeability. What is permeability? Material property. What material property? To allow magnetic line of force, because our discussion is magnetic line of force. Now what I do, I will take the ratio. The ratio, sorry, the ratio between permeability of a medium to permeability of a space is called as relative permeability. What we say? Relative permeability. So what is relative permeability? It is a ratio between permeability of a medium to permeability of free space. This mu is equal to what we write? Mu r into mu naught. If r is equal to 1, mu is equal to mu is equal to, so material permeability will be equal to when the relative permeability is 1, and whatever the unit of relative permeability, no units, and any dimensions, no dimensions. Okay na? Next, so permeability annam, that allowing lines may be easy or it may be difficulty. So that will be expressed in terms of chi, called as magnetic susceptibility. What we say? Magnetic susceptibility. Same word we discussed in dielectrics. Akkada kuda vachinda electric line of forces. Ikkada magnetic susceptibility, magnetic line of force. Okay. So what is mu r? Relative permeability. What is chi? Magnetic susceptibility. What is the relation between these two? There we studied epsilon r and chi. What is the relation between these two? Epsilon r is equal to plus same thing mu r is equal to 1 plus chi with respect to magnetism, same relation. Okay na? Next, another one is we can write expression for period in the form of mu is equal to b by h. Mu is equal to b by h. Another formula for writing mu permeability, which is given by b by h. What is b? Already we discussed. Magnetic flux density. H, field strength, applied field strength or magnetic field strength. H. The ratio between b and h gives you permeability. Mu is equal to b by h. Okay. Right. From this, b is equal to what I can write now? B is equal to we studied there in a previous topic. Okay. So I am not going there. After this, magnetic susceptibility. Okay. Definitions following or not? After this, magnetic moment. Okay. Already we discussed magnetic moment. How this magnetic moment is originated in the atom? Magnetic moment, you got an idea or not? What is magnetic moment? Product of pole strength and length. How this magnetic moment is originated in an atom, atomic level? Generally, atom contains what? Electrons, nucleus. They orbit. Electrons orbit around the nucleus. So that orbit gives magnetic moment. How? What are orbiting around the nucleus? Electrons are orbiting around the nucleus. What is electron? Charged particle. You studied the definition of the ratio between E and T is what? I think Q by T or E by T. You studied this equation. It is I. The rate of charge is current. I is equal to E by 2 or Q by T, where total charge Q is equal to NE if you write. So this is equal to NE by T. N is the number of charge carriers. If N value increases, current will be more, or same charges in less time if they flow large current. So what is I? Current. When the current is, when we see this current? Because of electrons, charges. What are the charges here? Electrons. When the electrons are flowing, what will be there? Current. Here what the electrons are doing? Orbiting. They are in motion, they are at rest. So what will be there? Current. Current carrying conductor will act as a magnet. So magnetism will be there or not? So orbital motion of electron contribute to magnetic moment. Next, along with this, another one is spin. Electrons has got two types of motion. Am I right or not? Electrons can type of motion untadi. What and what? One is orbital motion. ఇంకొక మోషన్ ఏంటి? స్పిన్ మోషన్ ఆఫ్ ఎలక్ట్రాన్. స్పిన్ మోషన్ అంటే there itself it will two types of spin. One is clockwise spin or anti-clockwise spin. So electrons are spinning, they are in motion, they are at rest, they are in motion, means current will be there or not. One minute. Right. So electron got how many types of motion? Two types of motion. What and what? Shall I wait? I can go now. Continue. So electron got how many types of motion? One is orbital motion, the other one is spin motion. Orbital motion, motion, current. Spin motion, motion, current. So atom, with respect to one atom, two types of motions are there. Some amount of current, some amount of magnetism. Like that, total summing, we may get final amount of current, final magnetism. It is going to show it. But general, in an atom, electron pair we are going to see. Maximum atoms, electron pairs, which will show magnetism. If you see such type of elements, unpaired electrons of D block elements, 3D block elements, like iron, cobalt, nickel, when you write electronic configuration of iron, cobalt, nickel, unpaired electrons will be there, and they will be in D block elements, D orbitals. So those unpaired electrons are responsible for some amount of magnetic moment, unpaired electrons. If they are paired up, resultant value is 0. If they are unpaired, some amount of magnetic moment we are going to say it. So finally, the reason for as well as spin motion of nucleus. Nucleus is also, it is in motion. Okay, the sum of these three motions, resultant value if it is 0, no, not equal to 0, depending upon the value, some amount of magnetic moment it is going to show. Okay, so this is atomic level. The magnetic materials are going to have magnetic moment, resultant magnetic moment, that is because of electron motion, spin motion, electron motion of orbits, spin motion of electrons, and nuclear motion. Together, resultant value may be 0, may not be 0. If it is 0, resultant magnetic moment is 0, not 0, smaller value or larger value, depending on it, it will show magnetic moment. In this way, the bodies are going to show magnetic moment, origin of magnetic moment. And this magnetic moment, EH by 4 pi m, EH by 4 pi m, and the value of this value will be equal to 9.27 into 10 Bohr magneton is a unit for measuring the magnetic moment at atomic level. Bohr magneton is used to measure the magnetic moment at atomic level, whose value is given by 9.27 into 10 power minus 24 ampere meter square, and the expression for Bohr magneton is B, which is equal to EH by 4 pi m. What is E? Please remember formula. For what purpose it is used? It is used measuring the magnetic moment of atomic systems. Atomic systems means atomic level. Magnetic moment we are going to measure in terms of Bohr magneton given by the formula mu b, which is equal to Eh by 4 pi m. ఇది ఎట్లా వస్తుందంటే I is equal to E by T, T is equal to 2 pi by omega. I is equal to E by T is the charge. Orbital motion. Orbital motion is on the actual omega is equal to 2 omega is equal to 2 pi n. N is equal to 1. So omega is equal to 2 pi by t. T is equal to 2 pi by omega. ఇక్కడ small t అనేది from this we are going to get magnetic moment, Bohr magnet. Okay. Right. So definitions understood everyone? Magnetic field, magnetic lane of force, magnetic flux density, permeability, susceptibility, relation between these two, permeability of free space, relative permeability, value, and how the from where this Bohr for what purpose it is used, and how a magnetic moment is going to develop in the substance. ఇంతవరకు క్లియరా? ఇప్పటిదాకా డిస్కస్ చేసిన ఇవే, కానీ ఇందులోకి వెళ్ళి కొన్ని ఎగ్జాంపుల్స్ నుంచి బయటకు వెళ్ళాం, మళ్ళీ సబ్జెక్ట్కి వచ్చాం. అప్లికేషన్ proportionality d pi by dt, rate of change of flux. So when the rate of change of flux is going to take place, induced EMF is going to generate. How the flux is going to change? Flux ఎట్లా మారుతుంది? రొటేషన్. కాయిల్ రొటేట్ అవుతున్నప్పుడు అది. మరి ఇక్కడ విచ్ లా ఇస్ ఒబేడ్? లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ. అగైన్ మైనస్ సైన్ వి టేక్. Why we take minus sign there? Actually that minus sign concept is given by Lenz's. Minus given by whom? Explained by whom? Lenz. What is that Lenz law? Induced current will appear in such a direction that it always opposes the change which produced it. Is a Lenz law. Enduku? Actually current is an energy. Can we create energy? No. We are transforming energy from where to where? Mechanical to electrical. Okay. That process, attraction repulsion, current is generated, attraction ఉంటే repulsion ఉంటుంది. అక్కడ repulse force రావాలి. Repulse force ఉన్నప్పుడు our hand is going to do, or externally we do work. ఆ వర్క్ అనేది కన్వర్ట్ టు ఎనర్జీ, ఆ ఎనర్జీ కమ్స్ ఇన్ ద ఫార్మ్ ఆఫ్ కరెంట్ అన్నట్టు. If external work is not done, without doing external work, current is not going to clear it is. Now next we are going to see classification of magnetic materials. Yes, try to remember the formula and value Bohr magneton. Okay, classification of magnetic materials. Actually, this is complete theory question. Generally, magnetic materials major classifying as dia, para, ferro, antiferro, and ferri substance, paramagnetic substance, ferromagnetic substance, antiferromagnetic substance, ferrimagnetic materials, diamagnetic materials, antiferro and ferrimagnetic materials. As per your syllabus, this is also an important question. What is what? Properties, examples. Complete theory question it is. Okay. So we classify the magnetic materials based upon the titles that we studied till now. Definitions నేర్చుకున్నాం కదా. What and what we studied? Moment. Okay. Magnetic moment, relative permeability, magnetic susceptibility. Using this, we are going to classify the magnetic materials. Okay. Or attraction property, attraction and repulsion. And examples also we are going to give. Let us which will be induced. All diamagnetic substance will be when they are kept in the magnetic field, and they do not have a permanent dipole moment. Second difference in the, they do not have a permanent dipole moment. So if dipole moment capital M Next difference, magnetic susceptibility. The magnetic susceptibility of a diamagnetic substance is negative. The magnetic susceptibility value, when you are going to calculate for a diamagnetic substance, it will be negative, and it is independent of temperature as well as external field, magnetic susceptibility. Examples: copper, so these are some salient features regarding diamagnetic substance. One more definition that I missed: magnetic moment. Magnetization. Sorry. As a intensity of magnetization. What is intensity of magnetization? Okay, made up of material A, another substance made up of material B. Okay, the magnetic moment developed in this material is M1, and the magnetic moment that is developed in this material is M2. Those two values will not be same. In terms of I, intensity of magnetization. I stands for intensity of magnetization. What is intensity of magnetization? Magnetic moment present for unit volume of substance. Magnetic moment present for unit volume. For unit volume, magnetic moment for different substance, it will be different. Automatically intensity also may be different. Okay, the magnetic moment that is developed for unit volume of a substance is called as intensity of magnetization. Expression for I is m by V. Tell me about the units of I. Units of I. What are units of I? What is unit of M? Ampere meter square. Meter. E is 0. External field is 0. H is 0. No magnetism, no magnetic moment. So that I will show in the form of circles. Okay. What I do? Some E is applied. Okay. So automatically because of E, because of I some H. That H is H naught. So because of H naught, what is inside? Dipoles. So the dipole will be, see the direction of E and dipole moment direction. Same or different? Opposite. So M will be there, but minus sign we are keeping. So the dipole moment will be created opposite to the field direction. That's why minus sign we write. Minus means opposite. So this body, if you keep in magnetic field, it will be attracted, it will be repelled. Okay. So these are about diamagnetic substance, and they do not have a permanent dipole moment. Hence, magnetic effects are very small. No dipole moment, no magnetic effects, and magnetization becomes 0. When you remove this field, This is the situation. No, addition will be 0 when external field is going to be removed. Okay. So this is about diamagnetic substance. Next, paramagnetic. Susceptible. What we are going to will be random. The spin alignment will be random. Chromium paramagnetic substance. These are used in lasers and masers. These are used in lasers and masers. What is laser and what is maser? Laser, laser rays, light amplification by stimulated emission of radiation. లేజర్ రేస్ చూసారు ఎప్పుడైనా లేజర్స్ సినిమాలు చూపిస్తారు చూడండి లేజర్ షో విన్నారా ఇక్కడ హైదరాబాద్ ట్యాంక్ బండ్లో ఉంది చూడండి ఇక్కడ కాకినాడలో ఉందా లేజర్ షో వాటర్ విల్ డాన్స్ యాజ్ పర్ ద లైట్స్ లేజర్ లైట్స్ ఆర్ యూస్ టు target to show a particular point in the picture which are very far from the person who is going to explain, and it is danger. Those rays must not be focused into eyes. Okay. Next, this is a temperature dependent. Paramagnetism is a temperature dependent. Here we use a temperature called Curie temperature. When the temperature is less than the Curie temperature, it is converted into diamagnetism. Above Curie, it is paramagnetic. So it is a temperature dependent. Okay. Dipoles are difference is mu magnetic substance. Relative permeability of a diamagnetic substance is less than 1. Paramagnetic substance greater than 1. One more difference is relative permeability. Diamagnetic substance is less than 1. Paramagnetic substance greater than 1. Attraction or repulsion. Examples. Difference is minimum based upon the number of marks allotted. You have to write the differences. Okay, na? Next, leftover one is what? Materials. The last one is ferromagnetic materials. Actually, what are ferromagnetic materials? I tell one example. ఎక్కడన్నా మీరు కంప్యూటర్ హార్డ్వేర్ దగ్గరికి వెళ్ళారా? కంప్యూటర్ హార్డ్వేర్ అంటే తెలుసు కదా? ఎప్పుడైనా సిపి ఓపెన్ చేశారా? మీరు చేశారా లేకుంటే ఎవరైనా చేయంగా చూసారా? రైట్. మీరు చేస్తే అందులో స్మాల్ స్క్రూస్ ఉంటాయి కదా, అవి చాలా లోపలికి ఉంటాయి. వేర్ హ్యాండ్ కెనాట్ గో, అంటే చేయబోదు అంత లోపలికి. ఆ స్క్రూస్ చేస్తాడు, స్క్రూ డ్రైవర్ యూజ్ చేస్తాడు. ఏం యూజ్ చేస్తాడు? స్క్రూ డ్రైవర్. ఆ స్క్రూ డ్రైవర్ స్పెషాలిటీ వాడి స్క్రూ డ్రైవర్కి ఉంటుంది. అది స్పెషల్గా ఎక్కడైతే వెరీ స్మాల్ సైజ్ స్క్రూస్ ఉన్నవి, వేర్ హ్యాండ్ కెనాట్ గో, దేర్ ఓన్లీ దే యూజ్ దట్ టైప్ ఆఫ్ స్క్రూ డ్రైవర్స్. సో వాట్ ఈస్ దట్ స్క్రూ డ్రైవర్? ఇట్ ఈస్ హ్యావింగ్ మ్యాగ్నెటిక్ ప్రాపర్టీ. ఇట్ హ్యాస్ గివెన్ మ్యాగ్నెటిక్ ప్రాపర్టీ. ఓకే. సో నార్మల్ స్క్రూ డ్రైవర్స్ ఉన్నవి, ఆ స్క్రూ డ్రైవర్స్ డిఫరెన్స్ ఏంటి? నార్మల్ స్క్రూ డ్రైవర్స్ హ్యావ్ మ్యాగ్నెటిక్ ప్రాపర్టీ, బట్ magnetic properties ఉన్నవి. Means what? The material that is used to make that screwdriver is ferromagnetic in nature, I can say it. Means it has got magnetism. It has got magnetism. So magnetism is there or not? So when external field is applied there, no, when external field applies చేస్తున్నామా, screwdriver current పంపిస్తున్నామా? లేదు కదా. Even though without applying field, external field, it is showing some amount of magnetism. The magnetism is showing అంటే magnetic moment ఉన్నట్టే కదా. magnet ఉంటేనే కదా. Such type of screwdrivers, when you heat such type of screwdrivers, they will lose its power of attraction. Losing magnetism is called demagnetization. ఏమంటాం మనము? Demagnetization. Magnetic moment is formed. Demagnetization ఏమవుతుంది? It is going to be ఒక మ్యాగ్నెట్ హిట్ చేస్తే it will lose its power of attraction, తెలుసా? Or if you shake it roughly, hardly, okay, heating or shaking hardly, it will lose its power. We call it demagnetization. Of magnetic moment, of magnetic moment comparing to dia and para. Dia la ఉన్నదా? అపో dia will be developed M with external field. Parallel some amount it is going to be developed. అంటే ఉంటుంది మ్యాగ్నెటిక్ మూమెంట్ ర్యాండమ్ ఓరియంటేషన్ రిజల్టెంట్ వాల్యూ 0, బట్ ఎక్స్టర్నల్ అప్లై ఏమవుతుంది రెగ్యులర్ ఓరియంటేషన్ సమ్ అమౌంట్ ఇస్ గోయింగ్ టు షో. What about this ferromagnetic materials? The possess some amount of magnet. That concept we explain by using oriented in a particular direction is called as domain, and a group of but a substance which is ferromagnetic in nature. This is theory. I'll draw one diagram. With that you will get some clarity. Ferromagnetic materials in ferromagnetic materials. So this supplies what? And what is specialty? Orientation. But when you compare the orientation of all the materials will possess some amount of magnetic moment. They show some amount of attraction. Now when దీనికి ఎక్స్టర్నల్ ఫీల్డ్ అప్లై చేస్తే ఏమవుతుంది తెలుసా? The domains which are randomly oriented అంటే diagram పదం చూపిస్తాను ఇప్పటిదాకా అమ్మా పేరుంది దీనికి పేరుందా దీనికి నేమ్ చెప్పాను అర్థం కాలే లెగ్ పెయినింగ్ యు ఆర్ స్టాండింగ్ వాట్ నైస్లీ లెగ్ విల్ పెయిన్ ఓకే యూ స్టాండ్ వెన్ యూ సిట్ కదా ఇస్ కాల్డ్ ఎస్ అది అయినాకనే పోతుంది రైట్ ఇది లైఫ్ హిస్టరీస్ తర్వాత హిస్టరీస్ సో వేర్ వి ఫైండ్ దిస్ ferromatic in the absence of external field regular remaining rotate already if it is in the direction its size is going to increase so what is it biotic substance negative substance positive and small aromatic substance positive and large positive and large example for ferromatic substance iron cobalt nickel iron this is also temperature dependent ferromatic materials are also temperature dependent We compare this with respect to previous one. Previous one is what? Dipole orientation. In this case, parallel, anti-parallel. Where we see this? In anti-ferromagnetic materials. Okay, and this will show anti-parallel alignment exists in a material below a critical will be there up to a temperature called as critical temperature. That critical temperature is called as Néel temperature. The alignment is exist in material below a temperature called as Néel temperature. It is small and positive. Size small and positive, and it is also see the constant is the temperature, it is the critical temperature, Néel temperature. When the temperature increases, susceptibility increases and reaches a maximum value to temperature called Néel temperature, beyond which it decreases. Iron oxide, place iron oxide, manganese oxide. That's some one is ferrimagnetic materials. Simple. Ferrimagnetic materials alignment will be ferro alignment dipoles in ferric. Difference notice? Any difference is there or not? Keeping what? Ah, great. Show your copy. Show. Show. Turn your copy. Show to me like this. I thought that you are trying. Ferro. Anti-ferro. Tell me, what difference you notice among these three? Any difference on the difference? All are oriented in the same direction. Are anti-parallel alignment with the equal and when say result lines. Remaining dependent, independent, exact can include one more statement. What types of hysteresis? Example, time H versus I. H versus I. You will get a closed picture like this. This is called hysteresis curve. Am I sure? Hysteresis closed picture by taking H on x axis, I on y axis. corresponding material, magnetic material. I want to convert it into magnet. I want to convert it into magnet. Slowly I am increasing it value. Also, మీరు 75 minutes క్లోజ్ చేస్తా up to saturation HC H. Yes or no? Increase H. Increase here మైల్ ఉందా లేదా retaining property. So H is 0. Retentivity. Applied field is 0, but if I increase, it is increased. If I decreased, further increase, I make it further less H value. Opposite H I am going to apply. Decrease, decrease. H 0. Right. What is I? But H is 0. So minus. This point is called as coercivity. That point is called as, so the negative H which is applied in the here, which is say I is decreasing and finally become 0. But when I is becoming 0, the negative H is there. And see this minus T. Saturation in the negative direction. Further smaller H also you apply, it won't show. There only it is going to stop. Now, what you again value 60 this is loop or 60 this is curve. Only curves are joined or not. So from these two things we can know, one is R, other one is C. What is R retentivity? What is retentivity? Retaining property. When H is 0 but I is not 0. I is 0 but H is not 0. To make 0 0, if hard. Uh, Relative permeability and magnetic susceptibility, these values this is high, that these are small, density value of soft magnets are small, hard magnetic materials are large. Low currents. Metals. Alloy. Example, iron and silicon alloy comes under soft. Steel, these are used to make, these are